fire piston is a really cool piece of gear that can start a fire without using any type of spark or flint. So I'm going to show you how to make one, and then I'm going to explain how it works. To make a fire piston, you'll need a 1/2 inch diameter copper pipe and an end cap to go along with it, a 1/2 inch diameter dowel, some O-rings, sandpaper, and some glue. First, you'll want to measure and cut off about 5 inches of the copper pipe. You'll most likely get a rough edge, so make sure you sand it down to make it smooth. Next, you'll want to glue on the end cap. Make sure you make a good seal so that no air can get in or out. Then you'll want to take your dowel and cut a piece a few inches longer than the pipe you just cut. It doesn't fit into the pipe right away, so we're going to use a hand drill to sand it down, and I noticed that my dowel was too big to fit into the grips of my hand drill, so I had to sand it down to make it fit. But once you got it in your drill, carefully sand it so it'll slide smoothly into the pipe. Next, we're going to attach the O-rings. So with a file, carefully etch out some grooves so that the O-rings will fit snug around the dowel. I used 2 O-rings, but you could also do it with just 1. I noticed that the end of my dowel wasn't flat, so I sanded it down so that it would sit well at the bottom of the pipe. Once it's all leveled out, carefully drill out a groove where your char cloth will sit. And there you have it. Now that it's all built, let's see if it works. Okay, so it actually works. Now, you'll notice that there wasn't any spark, there wasn't any flint, so let me explain the science behind how that works. The fire piston revolves around the ideal gas law. If you don't know what that is, it's PV equals nRT, which is pressure times volume is equal to the number of moles, or how much gas there is, times the gas constant R, that never changes, times temperature. We need to compare 2 different instances, or states. The first state is when the piston is all the way up at the top. The second state is when the piston is all the way at the bottom. In both of these instances, we'll apply the ideal gas law. You'll notice that since the O-ring makes an airtight seal, the amount of gas isn't changing at all. Also, R is the same in both cases. If we do a little algebra, we can rearrange these equations. Since the left side of each equation is the same, we can set them equal to each other. To make it a little easier to understand, instead of an equal sign, we'll visualize it as a scale. If you remember, state 1 had the piston at the very top, and state 2 had the piston at the very bottom. It's easy to see that since the piston is pushed all the way down in state 2, the volume inside the cylinder, or copper pipe, is a lot smaller than in state 1, which makes the 2 states unequal. To fix this, we use something called Boyle's law. Boyle's law basically says that in a closed system like we have, as the volume decreases, the pressure will increase. This makes a lot of sense when you think about it, because when you push down on the piston, the farther down you push, the harder it gets. The piston even pushes back up after you let go. So I need to pause here because you're probably saying, okay, this has nothing to do with temperature and you haven't said anything about that yet. Well, everything I've said up to this point does relate to temperature and how it changes. Now, without getting too deep into it, we can figure out how much the temperature changes through thermodynamics. Now, the gist of it just says that as your pressure increases, your temperature will also increase. But how much that changes depends on what's inside your piston, like air or diesel fuel. So with that being said, we know that the pressure and temperature will both increase, balancing out our equation. That temperature increase is what causes that char cloth to burn. So there you have it. That is how a fire piston works. If you like this video, go ahead and like and subscribe. If you want to see any other gear tested or explained, go ahead and comment below, or even if you just want to check my math, go ahead and let me know.